Number 8 relates back to number 7, the factors we just came up with, the 5 factors that could increase reaction rate. And so number 8 wants you to explain how each of these factors actually causes the increase in rate to occur. So looking at the kinetic molecular theory or the collisions involved, how does each actually cause that increase? So an increase in temperature is going to have 2 effects. It's going to increase the total number of collisions. And if you have more collisions, the possibility of a successful collision is going to increase. And it also increases the energy per collision. Okay, it means that not only do particles collide more, but they collide with more energy. And what you're often asked is which of these has the greater effect, and it's the energy that has the greater effect, because it doesn't matter how many collisions you have, if they don't possess the activation energy, they won't be successful. So you can either increase the total number of collisions or increase the energy per collision. You'd be better off increasing the energy per collision. But temperature does increase both. The second one, pressure, increasing pressure or decreasing volume. Remember, this works for gases only, and the reason why is it's like increasing the concentration. You are crowding the gas particles, and anytime they're crowded, they are more likely to collide. And colliding is the first step in creating products. So this one also increases the total number of collisions. Looking at our third option, increasing the surface area of a solid reactant. Again, remember, this is only going to work if that solid is your limiting reactant. If it's in excess, it's not the one slowing down the reaction rate. But if it is the limiting reactant, when you increase the surface area, you increase or expose more reactant particles. And when you expose more reactant particles, collisions are more likely. Or the collisions with those reactant particles increase. So of the 3 we looked at so far, all 3 of them increase the number of collisions. Temperature also increases the energy of the collisions. So increasing collisions, definitely a common way to increase reaction rate. And no surprise when we look at concentration of reactants, the 4th one, to increase the concentration of a solution being used as a reactant. Again, assuming it's the limiting reactant, the one that was slowing the reaction rate down, you crowd the solution particles more. And when they're crowded, that will increase the number of collisions. So all 4 of these increase the number of collisions. The 5th one is the big exceptionist, adding a catalyst. Adding a catalyst has no effect on the number of collisions. It has no effect on the energy of the collisions. So it's important to know what it doesn't do. It doesn't affect if I could spell here, number or energy. What it does do is it does decrease the required energy to make product, which remember, that's what we call activation energy. So somehow it decreases the activation energy. And I liken it to moving a child closer to the target or making the target bigger for a kid to hit. You somehow make the requirement easier, and even though the kid doesn't do anything different, they're more likely to be successful.